It's Mr. Wolf here, and I'm going to be going over the scenario preparing for the next exercise. So the first thing I'm going to do is I'm going to answer questions on my scenario sheet. So reading through my scenario in terms of what type of molecule am I dealing with, it says carbohydrate right here. So I know that I'm dealing with a carbohydrate, and it also says that I need to build up a carbohydrate storage molecule. So I know that I'm making a molecule chain. So I've answered these first two questions. And then did anything happen to the reactants beforehand? No. And again, the reason being is really what we're doing is we're taking a monosaccharide and we're just making a polysaccharide. So nothing fancy there. So what I'm also going to do is the question's asked right here. So I'm going to say, nope, nothing happened to my reactants beforehand. And then finally, circle where this process is occurring. And so what I'm doing is I'm making this polysaccharide storage molecule. I'm going to be storing it in my muscles. So the next time I exercise, I can break that down and use the glucose for energy right away. So I'm going to circle the muscles of my guy right here. So it looks like I've answered all my questions on the biomolecules scenario sheet. And now I'm going to go to modeling the reactants and products of this reaction. And in this case, I'm making my molecule chain. It's a carbohydrate. So using my guide right here, I know that I'm going to need to make a monosaccharide or 3 glucose molecules. And glucose also has the H's at the ends, as well as an OH. And then these molecules are going to combine to make our polysaccharide for storage. And looking at my molecule, I need to have this H right here and an OH right here. Okay. So I'm not done yet because remember when we model this reaction, whenever you form these glucose molecules, the H and the OH get cleaved off and then they form a water molecule. So in this case, if this molecule was going to attach to this one, that H would have to get taken off and this OH would have to get taken off. So I'm going to have one water molecule here. And then it looks like this one right here stayed. And then if I want to bring this one and attach it to this one over here, this H needs to get taken off. This OH needs to get taken off too. So I'm going to make another water molecule. The other way I could check to make sure if I did this right is I count these up and I have 6 hydrogen atoms and I have 3 oxygen atoms. And then the atoms that make up my glucose right here and then my polysaccharide right here, those all will just remain in them as well. All right. So I've modeled my reactants and my products correctly. Next thing I need to do is just kind of summarize everything we just did. So it's really nothing new, it's just putting it all into one nice sentence or two. And so in the muscles, so this is where this process occurs, cells take monosaccharides, that's the specific monomer for a carbohydrate, called glucose, and I need to use the term glucose as well, and combine them into a polysaccharide, the polymer of a carbohydrate. And then finally, I just need to explain why is this process happening. So, in the muscles, cells take the monosaccharide called glucose and combine them to form a polysaccharide. So the next time you have energy, you have a store of molecules that can be broken down right away and help you out.